Okay, so welcome everyone. My name is Jakub Kubrynski, and I'm going to talk about introducing infrastructure as code, how you can do that, how you can simplify that, and how to make it more maintainable. So, about me, I work as a co-founder at DevSkiller company. I'm also working as a trainer of the in the Bottega company. I'm a program committee member of DevOps Poland, and I'm an active open source contributor with the last project of Spring Cloud contract from the well-known. Okay, so what does the infrastructure as code mean? So if you take a look at the Wikipedia definition, then you can see that the infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. So that's obvious generally, but the first question is, what do we mean by the computer data centers and what do we mean by the infrastructure? So when we take a look at the infrastructure definition, generally it can be everything, okay? So if we have some bare metal machines, of course, it's hard to automate creation of the bare metal machines, okay? It's hard to create a, I don't know, machine-readable file that will install, the computer in the rack, okay? But everything starting from the hypervisor can be automated and can be treated as an infrastructure in case of this infrastructure as code paradigm. So we have a hypervisor. Virtual machines that are running on this hypervisor are also treated as an infrastructure. Operating system, it's also infrastructure, right? Configuration of this operating system. So creation of the users, I don't know, creating some directories, like mounting drives, etc. Everything works as an infrastructure. If we have an application build pipeline, so with a way of compiling our application, deploying it, it also can be considered as infrastructure. Some deployment scripts that just deploys my application on the production, it's also treated as infrastructure, as well as the configuration of the application, okay? If I need some, I don't know, database passwords, some properties of my application, it's also something that I can consider as an infrastructure. So all those elements can be treated as the infrastructure, and all those elements can be automated. So now the question is, why should we even think about automating this stuff? So there are different answers depending on the context you are working on. So first thing, I think the most important one is the recovery time. Okay, if you have your own production environment that is running on some cloud environment, let's say that this cloud environment is destroyed right now. Okay, it didn't exist from now. So how much time do you need to recover from that situation? Okay, if it's something that I need to click, go through some processes, web applications, etc., it's hard to estimate the time needed to recover. Okay, if I have automated stuff, then the first thing, I know how much time do I need to recover from such situation. But the better thing is that if everything is automated, I won't forget about configuring something. Okay, it's common. When before automating stuff, we're migrating or creating a new server, all the time it was, why it's not working? I've done everything. Did you configure something? Ah, sorry, I forgot to open a firewall. I forgot to do something, okay? So that's the problem. You can have it in the documentation, but as long as documentation is not maintained automatically by the code, then it's hard to say that it's actual, okay? So the first thing is the recovery time. Second thing is backup complexity and backup efficiency. If you don't use the infrastructure as code, it means that the master of the configuration is on all machines. So the machine is itself master of its configuration. Okay. So if you want to backup the machine, you need to backup everything. EDC configuration, all files. So general people just back up the whole machine. Okay, backing up the whole machine takes time, takes space, and it's inefficient. If you have scripts that configure this machine, you don't need to bother with configuring the etc directory, because everything that is in this etc directory has been created by your own scripts. So as long as you have those scripts, you don't need to back up the result of these scripts, because you can recreate it at any time, which also improves your portability. If you want to migrate your applications from one server to the other, then it's extremely easy, because it just means executing the scripts with different parameters. The result will be the same, okay? Of course, the infrastructure and the architecture will be more readable, and it will be much easier to understand it, because you can see in the code. You can do the reverse engineering of your architecture and your infrastructure based on the scripts, based on the source code, okay? So that's extremely easy then to check, okay, so what's the configuration of my firewall? I don't need to dig into the operating system, try to invoke some complex commands to see what is the IP tables result. No, I have a script that is opening all ports. So I know just by looking into my Git repository, what's the status, what's the state of my architecture, okay? Also, it improves the simplicity of the architecture, because let's say that we'll say, okay, let's say that if the application is called a store, it produces the artifact that is called a store.jar. That's our agreement, okay? There is no way that I can enforce you to do that. But if we use infrastructure as code and we have one script to deploy all applications in our company, if your artifact is using or following the different naming convention, it won't work. Because the script assumes that the name is the name of the application.jar, okay? That's the enforced convention. So it's much easier to keep it simple and clean. Last but not least, we have the whole history of changes to our architecture. Okay, we have also the auditing mode on all the time. Because if anything that you want to do to your infrastructure, you need to do through the Git repository, right? There is a mark, there is a history in this repository that something has been changed, that someone has opened the firewall port. Often there is also this commit has a context of some Jira issue that you can dig in and check, okay, now I understand why this port is open. Now I understand why someone added this stupid flag to the JVM. I know it. There is a description. I see who did it, when, and why. Okay, so that's the giant advantage of infrastructure as code. So how can you start introducing infrastructure as code into your organizations, into your teams? So the general problem that I see continuously is that there is a lack of competencies, lack of people, lack of time. So we want to do that, but there is no time to do that. And that's in fact not true. Why? Because if you will focus on most time-consuming things, you will win. Why? Because imagine that you are deploying your application to production environment and to stage environments like 10 times a day. Okay? Let's say that this process takes you like 10 minutes. Okay? So it means that you are spending almost 2 hours every day on deploying stuff done manually, okay? So then, if you automate this stuff, you will get the return from this investment very, very shortly, okay? So don't try to do everything at once. Focus on something that gives you the most value, the better value. Like this, for example, deployment. So automate things that you're doing continuously all the time, okay? And the title said that we are going to implement this infrastructure as code with conventions. Why conventions? What do we mean by convention? So how we compare the convention to the configuration. So we can say that convention is like a function. Okay, convention is a function that, for example, maps the name of the application to the name of the jar. That maps the name of the repository to the name of the application. that maps the name of the application to the list of the hosts that this application will run. Okay? And on the other hand, the configuration is just like a result of this function. Okay? So if I have a file with different informations, like application name store, user that it runs store app, okay, the Linux service that starts and stops this application, store minus service, etc., etc., etc. Okay, so that's the configuration, and I need to keep it for all of my applications, all of the components separate. And of course, I can change it. I can say, okay, so now this store application won't use the store repository. It will be in store2 repository. Okay, no problem. You can put anything you want into the configuration. Okay, at the same time, if you follow the conventions, it's not possible because you have one convention. Okay, and this convention enforces that you should do it that way. Okay, so if you want to start working on infrastructure as code, start introducing infrastructure as code, start from introducing basic conventions. What do I mean by basic convention? First thing, we can assume that the name of the application should be equal to the name of the repository which keeps this application. Okay, so if you have an application called the GeeCON, it should be in the Git repository called GeeCON, and it should produce the artifact target/geecon.jar without version, without anything. That's my convention. Okay? So that's the first thing you need to do, because without conventions, you will have a lot of configurations. You will have extremely complex deployment scripts, because to deploy the application, you need to first check out what's the what are the servers that this application runs, what's the application user, what's the service name, what's the artifact name that you need to copy. Okay, where are the properties to this application? So those all scripts, pipelines, configurations, etc., will be extremely complex. And probably you will fail. You will say, it makes no sense. It takes me so much time to automate it that I don't want to do that. Okay? So the idea is start with basic conventions. And the first thing you should do is to clean up your Jenkins or some other CA tool with Job DSL. Job DSL is the first tool that we'll see today. So how it looks like. It's the sample of the Job DSL. Job DSL is a DSL written in Groovy to automate creation of the Jenkins pipelines, builds, artifacts, etc. So something that you can see here is just an example taken from the documentation of the Job DSL. And what's wrong here? Check what are the important factors here. So I have a job name. It's in this case example, right? I have a repository that is here. I have some command and I have some artifact. And now let's say that we want to introduce the same configuration for other plugin, because now we have a Job DSL plugin, and let's just copy paste it to have also the, I don't know, Git plugin. So let's say that it will be in the Git plugin. Maybe it will be just a Git, and then it will be, I don't know, git2.hpi. What's the problem now? Okay, I need to maintain two scripts. They are similar. I can try to extract some, abstraction to do that, but still I need to parameterize it. I need to keep some maps of all these parameters, which I don't want to do. Okay, what I can do on the same hand. Let's remove this completely. And now let's say, okay, so first thing, I'm building the Job DSL plugin. Great. So the name of the job should be a Job DSL plugin. Let's say build. I don't know. right? Okay, there is the job DSL plugin, but I want the artifact to be called also the job DSL plugin. And why it's important? It's important because now you can do something like this, right? And introduce the plugin name. It won't work because not wrong. Let's ignore it. And now you can say that the plugin name is equal to, let's say, job DSL plugin, right? And the good thing is that now you can do something like this. Each plugin name. Okay, and we'll do something like this. And now I have a configuration and I have a convention. Where are the conventions? First convention, second convention, third convention. These are the conventions. They are functions that are converting some input to the result configuration value. And now, if you want to add some other plugin, you just are doing like this one. Okay, it's extremely easy to maintain it. Now, if you want to migrate to Java 9, done for all of my applications. If you are, for example, using the microservices architecture, when there are a lot of microservices, a lot of components to maintain, you need to follow such simplifications to be able to maintain it. Okay? And it's much more simpler than doing it on the other way, right? So that's the first thing that you can do. And I think that you should start, if you want to introduce that, with this one, with cleaning up all your build system. And now let's say that, okay, so we have already cleaned the Jenkins. So now let's clean the infrastructure. Okay, so we can use the same principles in the infrastructure. So we have created a tool that is a DSL that is generating a Terraform script. Terraform is a tool to orchestrate cloud infrastructure. So how it works? So let's say that I will define the GeeCON production Azure okay, it makes sense. Region within West Europe. Okay, and what it does, it generates the, let's say here, the resource group with the name prod GeeCON West Europe resource group with some tags, names, locations, etc. And now let's say that I want to define a network, because we need to start with the network. A network has some ID. Let's say this ID is equal to 1. So now I run this script and it generates the network. And what's important here, as you can see, this network is related to resource group name. There is no direct relation in my script, but I don't need to do that because it's the convention. Okay, it's the convention that all elements defined inside the resource group are related to this resource group. So now let's say that I want to also define a subnetworks. And I want to define a subnet, let's say the VPN with subnet ID equal to 10. Let's see what happens. Okay, so now we have the subnet defined with relation to the virtual network, and it's also done automatically. Okay, and now let's say that we want to define a component. We want to define a VPN component. Okay, and this VPN component will contain a public IP and will create an availability zone, etc. And if we run it, you can see that all these things are merged automatically. Okay, so if you want to, for example, now define a virtual machine, let's say that we are going to define a first virtual machine with some default stuff. As you can see, this virtual machine is linked with the availability set that was defined earlier here, which is linked to the resource group, etc. So everything is linked automatically by convention, and the difference is that here I have like just few lines of code, and it produced the giant amount. Of course, I can do here something like this. I in 1.10 I. Okay, and I can generate it automatically. It's of course huge, but everything is configured automatically. As you can see, all the names of the elements, etc., they are generated automatically using some functions. Okay, so that's the first thing that you can do: automate the stuff. If you are going to use Ansible, Terraform, it doesn't matter. Just remember that all those relations and names should be managed automatically. And the third thing that you can do is to clean up the whole operating system using tools like Ansible, like I have here. Okay, here I have a user that is called a store up. I know that it should be store. Like the application service is called a store service. It should be store. Also, this needs to be store. This needs to be store. This needs to be store. And what I can do now is to just do something like this: application name. Okay, and that's the convention. Now you can reuse this script for all of the components inside your whole system. And if you want to create an infrastructure as code that is automated and that is maintainable, you need to remember about all those conventions. Without the conventions, you will fail, because you will have so complex infrastructure, so complex things that you will be unable to maintain, okay? Or you will spend so much time that you will say, okay, it makes no sense. Thank you very much.